Thank you, Larry, for that introduction. As Larry says, I'm with eThekwini Municipality, not actually city engineers. I'm in that building, but I've actually joined the climate protection branch, which falls under the environmental group. So that's the banner here, and I'm not sort of bound. I've only just started there, so I'm not really bound by their template, which has been criticised earlier in this week. But the reason I kept this template in is that it shows the beach, at least, and that's what this talk is all about. You can see my affiliations, myself with still with the University of Cape Town, where I've been doing a PhD in oceanography, and then my co-author, Alan Smith, is a geologist, research associate and part-time lecturer at UKZN Geology Department. Okay, just to take a little brief fly-through of photography. We've come quite a long way from the old box cameras in terms of going through to the next box, and then things got a little better, eventually with SLRs. But that's taken, if you look at through time, you've been able to get like sporadic photographs of beaches perhaps, and they can be useful. But then we've started to enter, since 1937, we had the first surveys of the coast, the first big survey. And again, that's sporadic, they're interannual. Then, since then, 1937, 1958 was the next one, and I think it was 1976, so, fairly sporadic. And since then, we've got a great help from satellites. Again, also, unless you've got a big budget, they are sporadic that we'll have access to. And then more recently, we've got drones, which have a couple of problems in themselves because they're essentially illegal in terms of airspace, so they have to be managed properly. All right, so webcams, they're a new age in technology to use. Well, maybe not so new anymore. Basically, very, very widely used, tourism and game viewing, that's been referred to during this conference. We've got camera trapping, motion and infrared triggered cameras, and here's one that was actually just taken last night, showing one that's in Kruger Park of a hyena drinking out of a swimming pool. We've got accommodation establishments that are using them to advertise their places. Traffic webcams have become quite popular. Weather watching for aviation industry, water sports, hiking. You can see that the graphics aren't that big, but that's of table mountain. So, in terms of beach users and beach webcams, it's a technology that's we've been latching onto because it's freely available, therefore low budget. So we've got the tourists again, surfers, ski boaters, divers, snorkelers, all wanting to check out what the sea conditions are doing, sunbathers, kiteboarders, kayakers, and then surf lifesavers, which actually Gavin referred to a little bit in his talk earlier, in the earlier session. And more recently, scientists and managers are starting to tap into this resource. There's a couple of sites here, which is Wavescape, one of the main surfing sites that can be used, and this is Hibiscus Municipality South Coast Web, running out of Margate. Right, pros and cons. It's free technology, so low budget. Webcams are fixed to give a consistent and comparable view. You can remotely assess the beach condition and the beach morphology, and you can get day-to-day. The main thing is we're getting the day-to-day variations, the tidal, seasonal variations, as opposed to, as I mentioned earlier, with Google Earth, aerial photography is irregular and interannual. The cons, some things that we can't control if we're getting the free service. Poor resolution, dirt on camera lens, no control in the location, the view, or the orientation. The camera might be looking into the sun at certain times in the morning. They're not all suitable for actual beach morphology use. Might be restricted views. Downtime you've got no control on, and discontinuation of services, which can be a problem when you're halfway into collecting a nice little data set. So, which we have had a few problems with. Just to take you through a few webcam locations along the KZN coast, Umhlanga Rocks, Umgeni, there was a traffic webcam, which is discontinued at the moment. That's Vodacom. In Durban, and I'll take a few more of those later in this presentation. Amanzimtoti, again, that's a Vodacom cam, and then, as I say, the South Coast Web, Margate area, there are quite a few down in that area, and I'll be just taking a few examples for this presentation. Okay, so the data, we've been collecting images since March 2010. We thought, well, this is quite a nice little free resource to get into. And we took it from the consistently available webcams. So Umhlanga, which is a topographically bound bay, Amanzimtoti, also topographically bound, plus an estuary in it. Margate, which is a headland-bound bay with 2 headlands on either side and just the beach in between. And we've been capturing images at low tide, just for comparative purposes. Although high tide images are also used very occasionally if there's tidal variations or storm surge events. So it's not as high-tech as what Gavin's got, but we've got to start somewhere. Right, now just to take you through a seasonal wave rose distribution, because that's going to have some bearing on the discussion later. This is the wave rose for Durban, produced by Steph Corbello and was Interpenny engineers, from the CSR wave rider data. And you can see that there are some variations. In summer, you've got your swells are more on east-southeast. You do have a sort of south-southeast component as well with cold fronts, but you get cyclone swells and high pressures dominant high pressures that sometimes will push in easterly swells. So that's quite important. Autumn, you'll get the odd cyclone still lurking around, so the odd east-southeast swell, and then you're starting to get more dominant south-southeast swells. And then winter and spring at the bottom, also more dominated by your south-southeast swells, but occasional events you can see in spring from the east. All right, now that is a bearing on the seasonal rotation of the bays. So in the case I've just taken 2 examples, and it's a fairly common occurrence along our coast. So basically in summer, you'll get deposition in the southern parts of the bay. So this is under your east sort of more easterly dominated swells. So you'll get deposition here and erosion on the northern side of the bays. In winter, the reverse is true. So summer, you can see Amanzimtoti, you've got a nice thick beach on the south, and you've got a little bit more erosion in the north. In terms of winter, you've got erosion, you've got a dominant rip current that will operate just in to the north of the headland. So that southern part of the bay gets eroded, and if you look at the reverse, you get some deposition in the north. You can see Amanzimtoti, suddenly your nice wide beach has now got eroded again. Remember, these images are all at low tide for the comparison. There's no differences in tides here. Okay, just to put you into perspective, this is Amanzimtoti, the webcam that I was looking at. I won't go into too much detail, but the webcam is looking from a block of flats, and then it's looking northward. So basically, you can see there's a couple of Google images. You can see this is the date here is October, and you can see that the rip current was quite dominant in this corner, October 2011, and you can basically see that there was a lot of sediment that was removed from this section. And the sediment's got to go somewhere, so it's got deposited in the north. The other images, you probably won't be able to see the dates very easily, but the one was March and the other one was in May. So you can see that there was more sediment available at the end of summer still, and that will be after summer rains have brought down a lot of sediment. And there's a little bit of a time lag with the seasons as the sediments get reworked. In terms of beach variability, this is just a quick little example of Amanzimtoti. You can see often, in most cases, the beach is actually straight along that section. But then, so this is during March, so we've got a nice straight beach, and then the rip current starts to just kick in. So we've got the longshore bar changing into rip cells, and you can see that rip cell actually migrates a little bit further to the north, and that will be with longshore drift having a slight influence there. So ultimately, you'll see that the current is there, and eventually it dissipates, and that's over a month period. So that was actually persistent. That rip current was actually persistent for a whole month. Now we've got to say, well, is that a response to bigger swells or direction change? And what we're finding out now is that the swell direction is pretty important. That's going to be some other work down the line. All right. Umhlanga Rocks is just a quick example of an erosion episode that we've been able to see using the webcams. The webcam is in this little corner on a block of flats, and it's basically looking southwards. And you can see just from the Google imagery, this is 6th of May 2011. You can see that there is more sediment at sort of the end of May, and often May is the month where you've got more sediment. That's just before the winter swells kick in. Whereas other months, June already, this is a June 2008, but you can see that a lot of sediment was already excavated or eroded from that point. Right, this is just an example of black rock. So you'll see here, the beach in May 2011 was nicely nourished, quite a lot of beach available. This is black rock in the corner. And during July 2011, we started having a lot of big south-southeast swells with cold fronts that were moving through, and quite sustained big swells during that year. And that's related to lunar nodal cycles, which I won't get into right now because it gets quite technical. Basically, you can see over from May to July, a lot of excavation away, of erosion of sediments, and basically by the time of August came, the rock is almost fully exposed. The bottom image, which is not very clear, this is why I'm saying we have problems with the, especially in beach environment, you've got a lot of deposition and moisture on the lens. It's not very clear, but the rocks were exposed, and local authority was getting concerned about the tourist season coming on the way, and there was a lot of infrastructural damage. So they were worried about, is there going to be enough space bums on beaches for the tourist season? So basically we advised, no, the sand will come back, which it did. By January, the sand had naturally started to replenish, and you can see by April the following year, your sand is back. In terms of infrastructure damage during this period, though, you can see 13th of July, there was this is black rocks, so that's that section we were looking down on. So you can see it was getting quite exposed. By October 2011, it was very exposed, and your Loffelstein walls were exposed in that section, and you had a lot of infrastructure damage, so slippage in front of the life-saving club, which required a lot of investment to re-establish. And if anyone of you know Granny's Pool, I mean, it was totally scarred of sand, with the sand all getting deposited in the beach rotation on the other side of the bay. And then you can see, just comparing the different views, by 11th of December, this is a similar sort of view to this area with black rock. You can see that the sand had started to come back. Unfortunately, with the lights, you can't really see the damage that was done to that area. Just to go through some quick management applications, I'm just going to take you through two contrasting examples of coastal management on the KZN south coast at Amanzimtoti and Margate. And the problem was we had above average rainfall 2011 and 2012 during the summer, and increased runoff and sediments being supplied to the beaches, and that inflated the beaches and prevented direct breaching of estuaries. So in the case here, estuary mouths migrated south, causing erosion of infrastructure. And I've been given the 5 minutes flag already. So basically what happened in the case of Margate, you can see October, lots of sediment. The estuary was coming out naturally through there. 24th of November 2011, the estuary had actually moved. But the main difference was in June of 2012, where you had flood events, and it actually resulted in the estuary starting to migrate south. And after that, you had the summer, where a lot of sediment was deposited. So that estuary didn't have a chance to breach naturally, and plugged up, and it started to migrate southwards. So this image here is high tide, and a lot of infrastructure was starting to get eroded. And basically local authority decided they're going to try and do this the right way. They appointed environmental consultants who then advised to try and breach the estuary in this section over here to avoid the problem. So, because this was eroding on this side as well. So they created an excavated channel, and put berms up to prevent the southward movement of that estuary. And you can see by the time January came, the tourists were quite happy. They could all get access now to the beach, which they couldn't. They would have had to cross the estuary. And by January, the end of January, had a nice big beach again with that deposition as occurs in summer. Just a couple of pictures of the damage. There was a life-saving premises, an Olympic swimming pool, and then the wall on the southern side. And then this is the sand being excavated and replaced. And that's the ramp going down to the beach. Okay, in the case of Toti, a little bit different. Metro Rail were contacted with regards to a problem because we've got a railway line in this instance. So the same thing, you had your estuary was starting to move south from August. There's a little weir over here which has previously been used to regulate the flow of the estuary. But basically, this is August 2012, September, you can see the estuary starts to move south. Then in October, 11th October 2012, the estuary actually did breach naturally. So you can spot that on your webcam. But it was still going to the south as well. And with a lot of sediment that came down with the rains, it actually just clogged things up and it didn't get a chance to breach again at that point. The result being that with high tides, this is a high tide 2 hours before high tide, you had an undermining of your railway line in this area here. So I had contacted Metro Rail from looking at the webcams and then going down, because there's no substitute for field work going on, and warned them of a possible problem. KZN Wildlife were involved, Sentosh is here smiling, and DEA, Omar Parak, and permissions were in place, but Metro Rail decided not to go ahead to breach. And the result was a disaster. The embankment collapsed, and you can see some emergency vehicles on the railway line in December. So 11th of December it collapsed. So that's just a few pictures of the collapse, the erosion of the embankment over here, the collapse of the train. Fortunately, 4 people injured, but no deaths, no mortalities. But they were really lucky that it wasn't a passenger train. Okay, just a brief, because I've got 1 minute left. So basically just a brief comparison of the management practices. In the case of Margate, they put an emergency response plan, an EMPR, environmental management program was put in. The further damage was averted, tourist season was saved. There were costs, but not anything compared to Amanzimtoti on the other side with a do-nothing. We ended up with a total cost of about 50 million to repair everything, putting geofabric bags in. And then Margate Beach has got a mouth management plan. Amanzimtoti had a retrospective EIA process. Okay, just briefly, observations. Webcams are useful tools for indicating changes in the state of coastline. I'm going to be told to stop, so I'm going to quickly go through. They provide more detailed analysis than aerial or satellite imagery can provide. Present coastal models are based on infrequent imagery, are incapable of describing the coastal environment in detail. And we're getting a lot of information we can never get before. And we can see that day-to-day changes can be quite dramatic. The cams are vital for planning. It can be used as an early warning system. And you can monitor estuary water levels for mouth closure, opening and breaching, especially those estuaries where wastewater treatments are. So, and I've been told to stop, so I've tried to convince the municipality to expand the network. There are CCTV cameras that through disaster management that I'm going to be currently trying to tap into now that I'm working at Etuary, I can get access to them. So hopefully to expand the network. And just to show how things are expanding in terms of just surfing webcams. We've got 7 webcams over a 4-kilometre stretch at Durban. Cape Town has got a number of webcams now as well. And future research, more detailed analysis to relate the beach state to the wave regime. Inclusion of beach profiles would be nice, so then you can get an idea of the volumes involved, of deposition and erosion. And for monitoring, long-term monitoring, effects of climate change, sea level rise. So, I'm just going to conclude on that. Fairly repetitive, but it can be used as a predictive tool for beach change and as an early warning system. And recommending that local, provincial and national authorities adopt this technology and install dedicated webcams to improve our knowledge and management of the coast, especially at the known erosion hotspots. So, any collaborations, anyone would like to come on board, and there's a couple of papers if anyone wants to refer that are under there of previous work that we've done. Okay.